So welcome back on this second video of advanced commands in Unix. So in this video, we're going to see how to use the awk command, which is a very popular function to analyze really big genetic data. So first, we're going to see the awk command, and then we're going to end by a quick introduction to regular expression that can be used through the awk command. Okay, so first, what can we do with the awk command? So the short answer is you can use the awk command to filter and format a text file. So for example, you can use the awk command to print some selected columns, for example, the first and the third one. But you can also print these columns only if the value of a different column is, for example, lower than 1. Also, what you can do is edit some columns, for example, removing 1 to the values of the third column or multiplying by some number. Or you can also use the awk command to know what is the minimum or maximum value of a column. So a more formal answer to this question is that O is able to scan a file line by line. So it's going to read the file and analyze it line by line, one after the other. It's going to split each input line into fields. So for example, the first field will be the first word and it will be stored in the variable $1. Similarly, the second word will be stored in the variable $2, and so on. Then it can compare input line or fields to some patterns. So for example, we can test if the second column is different from some number. And it can perform actions on matched lines. So it's useful for transforming data file. So for example, you can decide to remove some lines and columns or modify some numbers into some columns. So it's useful for transforming data lines. So for example, you can use awk to create a new file that has less columns and less lines, or you can create a new file for which you're going to modify some of the column of your original file. And it's also useful for producing formatted reports. So let's say you can use awk to read a file that contains all the results of a GWAS and only decide to print the results for the SNPs that have a p-value below some threshold. And finally, the programming constructs of awk are pretty straightforward. It formats output lines. It can perform arithmetic and string operation, and it can do some conditional analysis and loops. So this is the syntax of the awk command, which at first look not really pleasant. So what you can see is you have a space where you can specify some options. There's a space when you can specify some selection criteria, and there's a space when you can specify some action. And we'll see on next slides what are the types or options, selection, and action you can do. Then you need to put your input file, and by redirecting the output, you can create a new file that will contain all the lines you wanted to keep. So here is the most basic command you can use with awk, which is you're just going to ask awk to print all the lines from your file. So to do that, you just need to type awk space apostrophe. You open a bracket, you type print to specify that you want to print the line. You close the brackets, you use a second apostrophe, and you use the file you want to analyze. So here in this example, I'm using this command to look at the GWAS file, and I'm just going to pipe it to a head and a column function to have a bit better visualization of the output. And what we can see is just going to output all the lines of the file here. Here, it's another example where rather than typing print, we can type print $0 because the $0 variables contain the information of all the column in the line. Okay, so now let's say you want to print all the lines, but you don't want to print all the columns. So to do that, you're going to specify after print which column you want to keep. So in this example here, we want to keep the first column and the third column. And so if we use this awk command on our GWAS file, it will just output the first and the third column. So you can also decide to print some text in addition of the values that are in the columns. So for example, here we can type print, we open a quote, we type some text. So for example, the frequency of, followed by the column that contain the name of the SNP, followed by a new text is, followed by the column that contains the frequency of the SNPs. And then the output will be the frequency of, followed by the name of the SNP, is followed by the frequency of the SNP. So you can also specify some selection criteria to awk by specifying these criteria between the first apostrophe and between the first bracket. So for example, here, we're gonna ask to print all the lines that contain a pattern, and this pattern will be specified between slash in the awk command. So for example, here, let's say that we want to keep all the lines that contain the word false. Then we just going to specify this false word between slash, between the first apostrophe and the first bracket. And so for example, here, it will print all the lines that contain the word false. So in this particular example, you're observing that you're losing the header line of the file. So what you can do is slightly modify this function by asking to print the line only if you observe false or the word low to force it to print the first line of the file. So you can use also the awk command to perform some tests on some columns. So for example, here we can use awk with the if function followed by $1 = 1, meaning that we want to print all the lines where the first column, $1, is equals to 1. So let's go back and look at our GWAS file. We can test, for example, if the fourth column is equal to false. Okay. And as in the previous example, we can also force to print the header line by testing and printing only the line where the fourth column equals false or the fourth column equals low confidence variance, which is the column definition. We can perform also other type of comparison which are not equal. So for example, we can print if column 1 is lower than 1, for example. And so in this example here, we've decided to look at the number of SNPs where the p-value is below some threshold. So here we picked 10 to the minus 100. So of course we can perform other tests on the column. So for example, we can test if some column is below some threshold. So in this example here, we looked at if the 11th command, which contains the p-value of the association of the SNPs, we're testing if this p-value is below 10 to the minus 100, and then we decide to print only the SNP value and its corresponding p-value. And then what we can see is that it outputs two SNPs which have a p-value below 10 to the minus 100. When we do that on our file, on our compressed file that contains all the GWAS value, by first using the zcat function and then using a pipe to transfer all the lines to the awk command, we can do some tests on the p-value column and then using another pipe to count the number of SNPs with a p-value below 10 to the minus 100. So now let's say that we want to use this command on the compressed GWAS file that contains the results for all the SNPs. What we're going to do first is use the zcat function to print all the lines of the components file. Then we're going to use a pipe. We're going to transfer that to the awk command. And we're going to finish by a new pipe and the use of the WCL function. And it's going to print that there are more than 1,000 SNPs with a p-value below 10 to the minus 100. So another thing you need to know, you can also use the awk function to compare columns together. So in this example, for example, you can print the lines only if the value in the first column is similar to the value of the third column. And of course, you can use the awk command to perform some operations on the values of the column. So for example, you can decide to retract the value 1 to the value of the first column. And in this example here, we decide to print first the value of the first column, $1, then the value of the third column, $3, which is the minor allele frequency. And then you can decide to convert this frequency into a percentage by just writing $3 multiplied by 100 followed by the percentage character. And what you can see on the output is that all the frequencies here have been converted into percentages. So there are a lot of things you can do with awk by defining some variables at the beginning of your command, by specifying, for example, here that you have a variable called sum, which has the value 0. And by defining some variable, you can use awk to compute the sum of a column, to find the minimum of a column, or to find the maximum of a column. You can also set an awk variable to a shell variable, and to do that, you just need to use the option -v followed by the name of your awk variable equal to the value of your Unix variable. And then you can also define tab as the input separator or the output separator using the fs or OFS variable. So now let's end this video by having some really quick introductions to regular expressions. So what is a regular expression, or regex? So a regular expression is a sequence of characters that define a search pattern. It's mostly used with the grep function, but it can also be used with the sed function that we saw during last topic to modify some characters within a file, or with the awk function. And so in practice, it means that you're going to use regular expression to be very precise on the sequence of characters you are looking at. So for example, you want to precise that you are looking at a character that is at the beginning of a line or that is at the end of a line. So I've put here a list of the most popular regular expressions, and what you can see is that you have some regular expression to specify some set of characters you want to keep, or some set of characters you don't want to keep. So now I'm going to illustrate you the power of regular expression using the grep function on our file that contain information about genes. So in this first example, we're going to see how to find lines that starts with the character 1. And so to do that, we're going to use grep @1 that will specify that I want to keep the lines that start with the character 1, followed by the name of our file. And what we can see is that this command outputs all the lines that start with the character 1, which is highlighted here in red. So now in this example, we want to print the lines that start with the character 1, but that are related only to the chromosome 1. So to do that, we're going to exclude the characters 0 to 9 that follow the 1 by using brackets and a hat that will specify that we want to exclude the characters that are within the brackets. And so when we type this command, you can check that it only prints genes that are in chromosome 1. So now in this third example, we just want to keep the lines that end with the character 1. So to do that, we're going to use grep, and we're going to specify this by using 1 followed by a dollar, which means that we want to find this pattern at the end of a line. And as you can see here, all my lines end by the character 1. Now, in this new example, we want to look at all the genes that are HLA of class A, B, and C. So to do that, we're just going to grep HLA and specify between brackets that we want to keep the ones that are either A, B, or C. And as you can see, it only kept the genes that are HLA-A, HLA-B, or HLA-C. If we want to print all the other ones, which means the ones that are not A, B, and C, we just need to add a hat at the beginning of the brackets. And as you can see here, it prints all the HLA genes that are not A, B, and C. So now let's say that you are looking for some genes that contain the character A, followed by any character, followed by the character A, followed by any character, followed by the character A. To do that, you specify any character by using a dot. So the pattern you are looking at using regular expression is A.A.A. And so as you can see here, you have all the genes that contain the character A, followed by any character, followed by character A, followed by any character, followed by character A. So now let's look at the last example where you're looking at some genes that contain the character H and H, or H, C, and H. So to do that, you just need to use a star after the C character to say that this character can or cannot be present in your pattern. And so what you can see here is that all the genes have either the character HH, either the character HCH. So these are few examples of what you can do using regular expression. Of course, there are way much more complicated patterns that you can look at. But the idea here was only to introduce you of what you can do using regular expression. And so this was the last content on this video, and I'll see you on the third video of this topic 4.